Hello students, welcome to the second video on module 1, that is vector calculus. In the first video we have discussed some of the basic concepts of vector calculus. Now in this video we have to go on discuss some of the examples on that vector calculus. Before going to the examples, once again let us recall some of the important results what you have discussed in our previous video. First one, the vector operator del, and that is given by dou by dou x into I plus dou by dou y into j plus dou by dou z into k. That will be the first important result. Second one, gradient of a scalar function pi, that is given by del pi, which is nothing but partial derivative of pi with respect to x into y plus partial derivative of y with respect to y into j plus partial derivative of pi with respect to z into k, and this is a vector quantity, and the unit normal vector of pi is denoted as n cap and is given by del pi divided by magnitude of del pi, and the angle between the two surfaces, that is pi of xyz equal to c1 and pi of xyz equals to c2, is given by, that is so they may be pi 1 xyz equal to c1 and pi 2 xyz equal to c2, and it is given by cos theta equal to del pi 1 into dot product of del pi 1 into del pi 2 divided by magnitude of del pi 1 into magnitude of del pi 2, and the directional derivative of the scalar pi along the given direction d bar is given by the dot product of del pi and d cap, where d cap is the unit vector along d bar and is given by d cap equal to d bar divided by magnitude of d bar, and the maximum directional derivative value is given by magnitude of del pi, and this is along the vector del pi, that is gradient of pi. Next, divergence of a given vector f bar is defined as the dot product between del and that of the given vector, and it is going to be a scalar quantity, and it is defined as the partial derivative of first component of f with respect to x plus the partial derivative of the second component with respect to y plus the partial derivative of the third component with respect to z, and since it is free from ijk, that's why it will be a scalar quantity. And the last one, curl of a given vector, that is f bar, is defined as the cross product between the two vectors del and that of f bar. It is a determinant whose first row is the unit vectors along the coordinate system, namely ijk, and the second row represents the components of del. They are dou by dou x, dou by dou y, dou by dou z, and the third row is the components of the second vector, that is f bar. Its components are f1, f2, f3. These are some of the basic things we have to remember before going to the examples on the vector calculus. Now let us discuss some examples on that vector calculus one by one. Now let us discuss the first example, and the question is, find the unit normal vector for the surface x y cube z square equals to 4 at the point -1 -1 2. And now the unit normal vector is given by, as we have here, the unit normal vector is given by del pi divided by magnitude of del pi. That's why first pi is known and the point p is also given, that is -1 -1 2. First let us find del pi. Del pi is given by dou pi by dou x into y plus dou pi by dou y into j plus dou pi by dou z into k. If we differentiate this one with respect to x partially, keeping y and z constant, we will get a y cube z square into y, plus when you differentiate with respect to y, it is 3xy square z square into j, with respect to z, that is 2xy cube z into k, and this del pi to be evaluated at a point p, which is given by 1 -1 -1 2. They are the values of x y z. If we substitute x y z equals to -1 -1 2 in this one, we are going to get a del pi at p as -4i minus 12j plus 4k. Okay, if you are not satisfied, let us check that one. Here the first one is y cube z square. y cube is y is minus 1, its cube is minus 1, and z is 2, 2 square is 4, 4 into minus 1, that is minus 4 into I. The next one is x and y square is 1 and z square is 4. 4 into minus 1, that is minus 1. Minus 1 into 3, that is minus 12 into j. And the third one, if you multiply 4 and minus, that is plus 4, k will get. Now, and the magnitude of this del pi is given by sum of the squares of the components under the root. That is, square of this one is 16, square of this one is 144, square of this one is 16, as the components of del pi p are minus 4, minus 12, 4. And if you simplify, its value is going to be, that is 4 root 11 we get. And we know that the unit normal vector that is given by, that is n cap equal to del pi divided by magnitude of del pi. Therefore, it is del pi at p is given by minus 4i minus 12j plus 4k, and the magnitude of del pi is 4 by 4 root 11. For each term in the numerator, if you take 4 common, that will get cancelled with this. We left minus I minus 3j plus k divided by root 11. That will be the unit normal vector. That will be the required. Now let us go to the second one, and it is like this. Find the angle between the surfaces, that is x square plus y square plus z square equals to 9 and x square plus y square minus z equal to 3 at the point 2 minus 1 2. And one more question in the same fashion, that is find the angle between the surfaces x square plus y square minus z square equals to 4 and z equals to, that is x square plus y square minus 30 at the point that is 2 1 2, and this is there in the model question paper. Now let us take the first surface, that is x square. First let us go with the first example, that is here the first surface is x square plus y square plus z square equal to 9. Therefore LHS we can take it as pi, that is pi 1 is given by, first surface is given by x square plus y square plus z square, and the second surface is x square plus y square minus z, and the point P is, that is 2 minus 1 2. Now first, as we know, the angle between the two surfaces given by del pi 1 into del pi 2 divided by magnitude of del pi 1 into magnitude of del pi 2. That is what we defined here. First of all, we have to find del pi 1 and del pi 2 at the given point. And del pi 1 is given by partial derivative of pi with respect to x into y plus partial derivative of pi with respect to I into j plus partial derivative of pi with respect to k. If we differentiate this one with respect to x, that is 2x into y. If we differentiate this one with respect to y partially, that is 2y into j. Partial with respect to z, that is 2z into k. Now, this del pi 1 at the point P, that P is given like this, that gives you 4i minus 2j plus 4k, and its magnitude is given by square root of sum of the squares of its components, that is 4 square plus minus 2 square plus 4 square, that is 16 plus 4 plus 16, that becomes 36, and square root of 36 is 6. Now let us compute del pi 2, that pi 2 is here. Partial derivative of pi with respect to x is 2x into y, with respect to y, that is plus 2, I think it is plus, that is plus 2y into j minus, okay, that is z with respect to z is 1, that is k, and this implies, that is magnitude of del pi 2 at the point P is given by, that is once you take x equals to 2, that becomes 4y. Once you take minus 1, that becomes minus 2j, and that is actually it is minus 2j, and third one is minus k. And once you get the magnitude of this, that is magnitude of del pi 2 equals to square of this 16, square of this 4, and square of 1, that is 1 itself, that becomes square root of 21. And now the angle between the two surfaces is given by, that is cos theta equal to del pi 1 dot del pi 2 divided by magnitude of del pi 1 into magnitude of del pi 2. It is a dot product. Therefore, if you substitute the values of del pi 1 and del pi 2, and you have to take the dot product between them, and magnitude of del pi 1 is 6, and that of magnitude of del pi 2 is, that is square root of 21. And now once you go for, that is 4 into 4, that is 16, minus of minus, that is going to be uh, plus, that is going to be 4, and this is going to be minus 4, and finally we will get it as 8 divided by 3 root 21, and this implies theta is given by, that is cos inverse of this particular thing. Now coming to the second example, actually minus of minus, this should be plus and this should be minus, anyhow there will be a balance. And if you simplify, that is 16 by 6, that is 8 by 3 root 21, and get accordingly theta equal to cos inverse 8 divided by 3 root 20. Now coming to the second example. In the second example, the first surface I can take it as x square plus y square minus z square, that is pi 1. And the second second surface, if you take these two on the another side, that becomes z minus x square minus y square again. And here the given point is, that is 2, 1, 2. Now first let us get del pi 1. Partial derivative of this one with respect to x is 2x into y, plus partial derivative of this one with respect to y is 2yj, minus partial derivative of this one with respect to z is minus 2z into k, because del pi 1 is given by, that is 2 pi 1 by 2x, that is this one, and this one is into I, plus 2 pi 1 with respect to y partially into j, that is this one, that is 2 pi 1 with respect to z into k, that is this one. Now this del pi 1 at the point P, wherever x, y, z are there, if you take 2, 1, 2, that becomes 4, 2 and minus 4, that is 4i plus 2j minus 4k. And the magnitude of that one is given by square root of 4 square plus 2 square minus 4 square, that is 16, square root of 36, that is 6. Now let us take the del pi 2. Del pi 2 means pi 2 is already we are given like this, that is dou pi 2 with respect to x, that is minus 2x into y, dou pi 2 with respect to y, that is minus 2y into j, dou pi 2 with respect to z into k, that is k. If you take that one at p, and that is given by minus 4 and minus 2, and this is 1, that is k, and the magnitude of that one is square root of 4 square is 16, square root of minus, so square of minus 2 is 4, and square of 1 is 1, that is square root of 21. Okay, therefore cos theta equal to, it is a dot product of del pi 1 divided into del pi 1 dot del pi 2 divided by magnitude of del pi 1 into del pi 2, that is del pi 1 is given by 4i plus 2j minus 4k dot del pi 2 is minus 4i minus 2j plus k, and magnitude of del pi 1 is 6, and that of the second one is 21, and this results in, that is minus 16 minus 4 minus 4, that is minus 16 minus 4 minus 4, that is minus 24 divided by 6, that becomes minus 4 by 21. Therefore theta equal to cos inverse of minus 4 divided by square root of 20. That will be the angle between the two surfaces. Now let us go to the third one, and this is based on the directional derivative, and it is like this: find the directional derivative of, that is x cube yz plus 4xz square at the point 1 minus 2 minus 1 in the direction of 2i minus j minus 2k. Or one more is, find the directional derivative of pi equal to 4xz cube minus 3x square y square z at the point 2 minus 1 2 in the direction of, that is 2i minus 3j plus 6k, and this appeared in the model question paper. Now let us try to solve one by one. First let us concentrate on the first example, that is here the scalar pi is given by, that is x cube yz plus 4xz square. and the direction is given as that is 2I minus j minus 2k, and the point P is given by 1 minus 2 minus 1. These are the values of x, y, z. And we know that the directional derivative is given by that is del pi dot d cap, where d cap is the unit vector in the direction of d bar. First, let us calculate del pi, and that del pi is given by dou pi by dou x into I plus dou pi by dou y into j plus dou pi by dou z into k. Pi is given. Once you differentiate this one with respect to x, we find that is 3x square yz plus 4z square, because when we are differentiating partially with respect to x, we have to treat y and z as constant. Now this we have differentiated partially with respect to x into y. Next, partially with respect to y, that is x cube z. Okay, and here there is no y, it's 0 to 0, that is into j, plus I have to differentiate this one partially with respect to z, and it has to be multiplied by k, that is x cube y plus 8xz into k. And now this is del pi, and we have to calculate that del pi at this point, that is 1 minus 2 minus 1. Once we substitute x equals to 1, y equals to minus 2, and z equal to minus 1, we are going to get this one as that is 10I minus j minus 10k. We have to take x equals to 1, y equal to minus 2, z equal to minus 1. In each of the components, we are going to get this expression as that is del pi at p equals to 10I minus j minus 10k. And now we have d bar, that is the given direction, that is a given vector, and the unit vector in that direction is given by d bar divided by its magnitude. That d bar is 2I minus j plus 2k, and the magnitude of that one is given by square root of sum of the squares of its components, that is 2 square, that is 4, minus 1 square, 1, again 2 minus 2 square, that is 4, that becomes 9, square root of 9 is 3. If you go for individual division, that becomes 2 by 3 into I minus 1 by 3 into j minus 2 by 3 into k. Now the directional derivative is given by the dot product of del pi at the given point into, that is a dot product between del pi at the given point and that of d cap, that is unit vector in the given direction. And we know del pi at p, we have computed that one as 10I minus j minus 10k dot that d cap, that is 2 by 3 into I minus 1 by 3 into j minus 2 by 3 into k. Now you go for multiply the corresponding components and you add them. That is 10 into 2, that is 20 by 3, minus of minus plus 1 into 1 by 3, and minus of minus plus, that is 10 into 2, 20 by 3. If you take 3 as LCM, that gives you 41 by 3. That will be the value of directional derivative of the given scalar pi, that is given by, that is first one, that is x cube yz plus 4xz square in this direction at the point p equals to 1 minus 2 minus 1. In the same fashion, let us concentrate on the second example, which is there in the model question paper, and they are given the scalar pi, and the direction is 2I minus, okay, that is 3j plus 6k, and the point is that is 2 minus 1 2. Now let us get del pi. Del pi is given by dou pi by dou x into I is plus dou pi by dou y into j, as you have defined here, dou pi by dou z into k. First let us differentiate this one partially with respect to x. That gives you 4z cube minus 6x square, sorry, 6xy square z, 6xy square z. Okay, and that is a partial derivative of pi with respect to x. It has to be multiplied by I plus with respect to y. Here there is no y, its derivative is 0. Also differentiate this one with respect to y. That is minus 6x square yz into j. With respect to z, that is 12xz square. And if you differentiate this one with respect to z, minus 3x square y square, it has to be multiplied by k. Once you substitute in this one, x equals to 2, y equal to minus 1, z equals 2, and that is del pi at the point P is given by eta. If you take x equals to 2, y equal to minus 1 and z equal to 2 here, you will get it as eta plus 48j plus 84k. And also d cap, that is unit vector in the given direction. Here the given direction is this one, that is given by d bar divided by its magnitude. D bar is 2i minus 3j plus 6k divided by square root of the magnitude is given by sum of the squares of its components under the root of 4 plus 9 plus 36. That gives you 36 plus 4 40 plus 9 49. Square root of 49 is 7. If you go on divide individual terms, that is 2 by 7 into I minus 3 by 7 into j plus 6 by 7 into k. And the directional derivative along d bar is given by dot product of del pi and d cap. Del pi is given by 8i plus 48j plus 84k dot, and d cap is given by 2 by 7 into I minus 3 by 7 into j plus 6 by 7 into k. Now this one equals 2. If you multiply, that is 16 by 7, and this will be minus 48 into 3, that is 144 divided by 7, minus of minus plus, that is 84 into 6, that becomes 508 by 7. And once you take 4 by 7 as your common term, that becomes 4 minus 36 plus 126, and this becomes 4 into 94 by 7, totally it becomes 376 divided by 7. That will be the directional derivative of the given scalar in this direction at this particular, that will be the value. Now let us go for one more, and in this case they have given the vector, means they have given some vector, and for that vector we have to find divergence as well as curl. And the question is like this, that is find the divergence of f bar and curl of f bar, where f bar is given by del of x cube plus y cube plus z cube minus 3xyz, and the second one is if f bar equal to del of x y cube z square, then we have to find divergence of f as well as curl of f at the point 1 minus 1 1. And this second problem appeared in the model question paper, and also it appeared many of the times in the examination. And these two problems based on the finding the divergence as well as curve for the given vector. First, let us concentrate on the first example, that they are given f as it is del of x cube plus y cube plus z cube minus 3xyz, means it is of the form del pi, and del pi is given by, that is del is like this and pi is like this. Now each first one I have to differentiate this one partially with respect to x, and it has to be multiplied by I. When we differentiate this one partially with respect to x, it gives you 3x square minus 3yz into I, plus once you operate on the second term, it is when you differentiate with respect to y partially, that is 3y square minus with respect to y, that is minus 3x, is a constant, y with respect to y is 1 into j, plus when you differentiate this one partial with respect to z, treating x and y as constant, we get it as z cube, sorry, 3z square minus 3xy into k. That will be the thing we get there. Now this is of the form f1i plus f2j plus f3a. Now we can find divergence of f bar, and divergence of f bar is given by the dot product of del and f1 f bar, and that is given by dou f1 with respect to x partially plus dou f2 with respect to y partially plus dou f3 with respect to z partially, and this is our f1 and this is our f2 and this is our f3. When I differentiate f1 partially with respect to x, it is given as 6x. This is a constant, that is 0, plus when you differentiate f2 partially with respect to y, this is a constant, it will be 0, that gives you 6y. And again this is with respect to z, it is constant, it is going to be 0, and the derivative of z square is 2z, 2 into 3, that is 6z. And if I take 6 common, it will give you x plus y plus z. This will be an expression for divergence. Now let us concentrate on the curl of f. Now that curl of f is given by the cross product between del and f bar. And now first it is a determinant of first row is ijk, second row is components of del. They are nothing but dou by dou x, dou by dou y, dou by dou z. And f bar, we obtain here the first component, that is 3x square minus 3yz, then it is 3y square minus 3xz minus, so next one is 3z square. Actually we have write f1 f2 f3, these are one f1 f2 f3, that is 3z square minus 3xy. Once you evaluate this determinant, that is I into, operate this one on this minus this on this, that is I. When you operate this one with respect to y, you will get minus 3x, and minus when you operate this one on z, that becomes minus, this is constant 0, minus 3x, minus of minus becomes plus 3x, that is minus j. Leave this row, leave this column, operate this one with respect to x partially, this is 0, in that case you get minus 3y, and operate this one on this one, this is 0, minus 3y, minus of minus, that becomes plus 3y plus k into, you leave this row, leave this column, this will be operated on this, that is minus 3z. Okay, and it has to be operated on this, this becomes minus 3z, minus of minus becomes plus 3z, they will get cancelled, therefore that becomes a 0, right? We can write 0 or we can write bar on that seat. In the same fashion for the second example, first let us find what is f, and they are given f as del of x cube x y cube z square. First two, it is given by, this is pi, dou pi with respect to x partially, plus dou pi with respect to y partially, plus dou pi with respect to z partially into k. If I differentiate this one with respect to x, that becomes y cube z square into y. When we differentiate this one with respect to y, that is 3x y square z square into j, plus if we differentiate this one with respect to z partially, that becomes 2x y cube z into k. And this is of the form f1i plus f2j plus f3k. And divergence of f bar is given by del dot f bar, and that is given by if the components of the vector capital F bar are small f1, f2, f3, then divergence of f bar is given by the partial derivative of the first component with respect to x plus the partial derivative of the second component with respect to y plus the partial derivative of the third component with respect to z. When we differentiate, this is our first component, when I differentiate with respect to x, there is no x at all, it is as good as constant, derivative of a constant is c, plus when I differentiate this one with respect to y, that becomes 6xyz square, and when you differentiate this one with respect to z, that is 2x y. Therefore divergence of f bar is given by 6x yz square plus 2x y. That is your divergence of f bar, and in this case we want the divergence at the point 1 minus 1 1. Therefore when we take the value here in this one, if you take x equals to 1, y equal to minus 1 and z equals to 1, we get divergence of that one as, that is 6 1 minus 1 1 square. Okay, and the second one if I take here, that is 2, that is 1 minus 1 cube, to take here, that is 2 1 minus 1 cube, and this leads to minus 6, and this leads to minus 2, 2 plates value is going to be minus 8. That is your divergence of the given vector at the point 1 minus 1 1. Now the same thing we have to go for, in the same fashion we have to go for curl, and curl of f bar is given by del cross f bar. First row, it is a determinant of first row represents ijk, second row represents dou by dou x, dou by dou y, dou by dou z, and the third row represents the component of f, that is f1, f2, f3. In this case f1 is y cube z square, and the second component is 3x y square z square, and the third component is 2x y cube z. Now once you expand this one, Now let us see what we get if I differentiate, that is I into, if we differentiate this one with respect to y, that gives you 6x y square z, minus if you operate this one with respect to z, minus that is 6x y square z. It is minus j into, leave this row, leave this column. If you differentiate this one with respect to x, that gives you 2y cube z. And if you operate this one on this with respect to z, that is 2y cube z. And plus k into, leave this row, leave this column, with respect to x, 3x y square z square, minus if you operate this one, that is 3y square z square. They all get cancelled, and again we find it as 0 or 0 vect. That is the value of the curve at the point. Even though since it is 0, we cannot take the point in this case. Now let us go with one more. If f bar equal to, that is x plus y plus 1 into I plus j minus x plus y into k, then prove that f bar dot curl of f bar equals to c. First, anyhow we know f bar, we have to calculate first curl of f bar. Now first let us consider curl of f bar equal to ijk, that is dou by dou x, dou by dou y, dou by dou z. The components of the vector f1 is x plus y plus 1, and the second component is 1, and the third component is, once you multiply by minus sign, that becomes minus x minus y. And if we expand this one, and this is I, this is with respect to I minus 1, with respect to this 0 minus j, leave this one, with respect to x minus 1, with respect to, again it is 0 plus k, and leave this row, leave this column, this is 0, and this becomes minus 1. Therefore the curl of f bar is minus I plus j minus k. Now let us consider dot product between f bar and curl of f bar. F bar, they are given it as x plus y plus 1 into I plus j minus x plus y into k dot minus I plus j minus k. Then the dot product is, you have to go for multiplying the corresponding components, and you have to add. Once you multiply the first component with first component, that is minus 1, that gives you minus x minus y minus 1. Now the second component with second component, the second component in both the vectors is 1, their product leads to 1. Now the third one, this is x plus y along with the negative sign, this is minus 1 minus of minus becomes, that gives you x plus y, and again all will get cancelled, so we find it as 0. That's why we have proved that for this vector f bar dot curl of f bar is 0. Now let us go to the one more example, and they are given like this. If f bar equal to gradient of this scalar, then find divergence of f bar and curl of f bar at the point 1, 2, 3. They are given f bar like this. Now given f bar equal to this, sorry, they are given pi like this, and we want f bar. F bar is gradient of pi, they are given, and it will be given by dou pi by dou x into I plus dou pi by dou y into j plus dou pi by dou z into k. If we differentiate this one partially with respect to x, okay, we get it as 3x square y minus, okay, and here it will get it as a plus. Once we go for this one differentiating with respect to x, that becomes at cube, and this will be, if we differentiate with respect to x, that is minus 2 y square z square, plus if we differentiate this into I, if we differentiate this one with respect to y partially, that becomes x cube. If we differentiate with respect to y, that is 3y square z. If we differentiate with respect to y, that is 2x square y z square into j. Plus with respect to z means this is constantly, this becomes y cube, this becomes 3x square z, this becomes 2x square y square z into k. Now this is of the form f1I plus f2j plus f3k. Now we have to find the divergence of f bar, that is given by, if the components of f are f1, f2, f3, it is given by partial derivative of f1 with respect to x plus partial derivative of f2 with respect to y plus partial derivative of f3 with respect to z. When you differentiate the first component with respect to x, that gives you 6xy, and derivative of this one is 0. If you differentiate with respect to x, minus 2y square z square, plus if we differentiate this one with respect to y, this is 0, that is 6yz minus 2x square z square, plus with respect to z, this is 0, 6zx minus, that is if with respect to z, that is minus 2x square y square. And we want this divergence at the point 1, 2, 3. If you take x, y, z equals to 1, 2, 3 respectively, then this will becomes xy, that is 2 into 6, that is 12. If you take y square z square, that is 4 into 9, that is 36 into 2, that is minus 72 plus 6 yz, y is 2, z is 3, 6, 6 into 6, 36, minus 2x square 1, z square 9, 9 into 2, that is minus 80 plus xz, that is 3 into 6, 80 minus x square y square, x square y square, that is 4, 4 into 2, that is 8, and once you simplify this, its value is going to be minus 32. Means for a given vector which is given by gradient of this scalar, we are going to get this vector. If you calculate the divergence for this vector at the point 1, 2, 3, its value is going to be minus 32. Now let us concentrate on the curl of this. Okay, therefore the first component ijk, second component in second row are first. In general, curl of a bar is given by the determinant, whose first row is the unit vectors along the coordinate system, they are ijk, and the second row are the components of del, they are dou by dou x, dou by dou y, dou by dou z, and the third row represents the components of the vector f bar, they are nothing but f1, f2, f3. In this case, they are nothing but that is 3x square y plus z square minus 2x y square z square, and the second component is this and the third component is this. If you simplify this one, that is I into, if you differentiate this one with respect to y, that gives you 3y square, and this becomes 6x square z minus this one is going to be, if I differentiate this one with respect to z, this is going to be 0, that is 3y square minus, that will be 4x square yz. Now in the same fashion, minus j, if we differentiate, evaluate this determinant, we are going to get this. They will get this minus plus 3y square will get cancelled with this minus 3y square, and this will get cancelled in the same fashion. This will get cancelled with this will get cancelled with this, and now this will get cancelled with this will get cancelled with this, and finally we are going to get 0. Therefore, for this particular vector, that is f bar, which is given by del pi, where pi is this one, the curve at the divergence at the point 1, 2, 3 is given by minus 32, and the curve seems to be 0. These are the few examples on the basic components of vector calculus. And in the next example, in the next session on module 3, module 1, we can discuss some more examples on the basic concepts of vector calculus. Thank you.